I won't give you a ton of homework for the weekend. If you remember how all the calculus units work, where the first few days are nice and all of a sudden it gets difficult, okay? So we're in the first 2 days are nice. So this weekend, do your English ISUs and your physics seminars and everything else. Okay? Because next weekend, the weekend after, that's when your next choice assignment's going to be, and it's going to be fairly big. Okay? Not nightmare, but it's going to be a few hours. Hey guys, it's going to be 2 hours again. Okay, let's do this graph. If you can't remember how to graph these grade 11, that's okay. We'll go through these right now. The reason I'm doing this is because the basic graph, you have to know how to graph. Like the basic sine and cos graph, you have to know how to do going into this. In this course, we're going to be graphing off-roll sine and cos graphs, okay? So let's just start. Before I do that, I'm going to do a quick little graph on the right here of sine theta and cos theta. Okay, guys, can you stop talking, Austin? Austin, I'm picking on you right now. How do you draw sine theta, please?
Start at 0 and
Yeah, what's the highest point, what's the lowest point?
1 and -1.
Good. What is the period? Okay, so what I please, guys, can I please do this? This is very difficult. Okay, sine and cos are both the same. Right, guys? Sine and cos are both the same. I have put up here 4 points in the middle. I call those action points. That's from 1/4 of your period. Okay, so what is sine is going to start at 0 then. After a quarter of its period, it's going to go to the max, then to the axis, then to the min, and then to the bottom there. Okay, so that's going to be the graph of sine theta. Okay, that's hopefully not too strange for people. Okay, starting at the middle, I call those action points. It happens every quarter. Just to go from a unit circle. If you remember, I said that sine theta is equal to the y value. Okay, so at 0 degrees, it has a value of 0. At 9 degrees, it has a value of 1. At 180, it has a value of 0. At 270, it's a value of -1, and then back to 0. Okay, that's where that comes from. Somewhat okay? This is coming back to you? I hope so. If it's not, somebody please ask. You guys are way too nice. Okay. Cos, I'm going to do in the same way. Cos looks identical to sine. There's only one difference. What is the only difference? Starts with the maximum. Okay, that's the only difference between sine and cos. Okay, so here's 1, 0, there's -1, 1, 2, 3, 4, there's 1 or 2 pi. Remember, this is called a periodic function, meaning that it continues on forever. There's my beautiful graph of sine and cos, just like that. Okay, and again, where cos comes from, remember cos is your x value on the unit circle. So this is going to be when x at 0 degrees is going to value of 1. At 9 degrees, it's going to value of 0. 180 is -1. 270 is 0, and then 360 is 1. Come back from the advanced functions. No comment. We can keep going. What's the absolute axis? Period, action points, phase shift. This is back from grade 10. Can I get 4 brave volunteers to give me the amplitude, the axis, the period, and the phase shift? I will do the action points for you. The amplitude is in fact 3. Okay. Amplitude is the difference. Another word for amplitude would be vertical stretch. Okay, that's the amplitude. John, go ahead.
I want to say the axis is +1.
The axis is in fact 1. So that's going to be the vertical translation. Is that? What else do I know? Go ahead, Matt. Yeah, okay, so I write this as 2 pi over 2, which is equal to pi. If you remember Matt and everyone else, that's correct by the way, if you remember Matt and everyone else on last week, or Tuesday I guess it was, when I did the algebra for this, Kayla, when I did the algebra for this, and I said I added the period, I added pi, and it's like, oh, where'd that come from, 2 pi over k and all that stuff. This, you remember the period is affected by the number of the brackets. That's the horizontal compression, just like any transformation which you mastered before. What is the phase shift, please? Yeah, Dakota, go ahead.
4 to the right.
4 to the right. Remember, it's going to be in the opposite direction because it's inside the brackets. Okay, what it says. Action points I will do. This is going to be pi by 4 this is gonna be 1/4 of your period. So when I graph this one, Courtney, what I'm gonna do is, on my graph paper, every square is gonna be pi/4, just so I can have a nice little graph lined up. Is this coming back for most people? Sarah, I know you're tortured with this in grade 11, I know, okay? We did lots of this stuff, and I know if you're in Mr. Lacey's class, he did this in advanced functions last year. He didn't use, I think, the word action points, but everything else he did.
Oh, you did use action.
Did he use action points?
Pretty sure.
Oh, so I guess it was a made-up word I did. All right, let's go to the graph here. Graph says. Now, these fundamental graphs that we're doing aren't very important for this unit because, as I said, instead of just dealing with things like, instead of just dealing with graphs like 3 sine 2x, we're dealing with graphs like x sine x, to graph that, or like x cubed sine x plus x4. You know what I mean? Stuff like that. Stuff like that will be what you have to graph, okay? Sam, don't be upset, okay? I think that's like a biology challenge, this unit, okay? Think of it like that.
Where's the biology?
Well, it's the growth pattern of some species. Is what you're doing. Biology is all about periodic functions, isn't it? It's like the reproductive cycle of things and. No? Okay.
Just your laugh.
So here's going to be 0. 1, 2, 3, that's going to be pi. 1, 2, 3, 2 pi. I want to get to 2 pi. Please always check the domain for the graph, which you don't want to graph to. So I got to make sure my graph was at least to 2 pi. Please note I put 4 points between 0 and pi, right? Those are going to be my action points. This is a nice graph. My axis is going to be 1, so I'm going to put it right here. What does the amplitude give you? What's the amplitude? Michael, go ahead.
The distance from the axis to the max.
Right on. Okay, so I'm going to stretch this up. So that's going to be up to 4, 0, -1, -2. Right, so the way this worked, this was +3, that's -3. This across here is going to be my axis. Okay. So this is going to be your max. So right here's going to be the min. Is this starting to come back for some people? For some people, it's coming back, I hope. Okay. Now, no, John?
As in, it doesn't have to come back. It's there.
Okay, so the first point on the graph is going to be pi to the 4. It says the shift was pi to the 4 to the right, meaning this is my first point. Okay, so the first point on my graph is going to be right here. Can someone explain to me why it is right there? Oh, Caleb, go ahead. Yeah, okay, because basically, well, the reason, okay, yes, because the shift is pi over 4, so it's going to pi over 4 to the right. The sine starts at your axis, okay, so the graph sine starts at your axis, so that's going to be that. All right, Austin, what is the next point on the graph, please?
You're going to go up to pi over 2, which is going to be up to 4.
Yeah, so I'm going to go pi over 2 to the right, and then over 4. So, okay. So again, that's to give these action points. This is sort of every step on your graph to the right. Okay. This is starting to come back for some people, I hope. I don't know how other teachers do it, but this is how I do it. Next one's going to be the next pi over 2, so it's going to be there. Sorry, the next right pi over 4, and then down to here, and then down to here, and then down to here, down to here. My wife says, my in-laws live in Chesley, and I always say, they're going to come down to Owen Sound. And my wife goes, no, they're going up to Owen Sound. Not only is it north, Owen Sound north, there's no way it's voice. She doesn't sound like that. well, then also we're at a lower elevation, apparently we're at a higher elevation as well. So in no definition of, you can say, are they coming down to see us? Okay, but this bugs her, and I say it probably about once a week. All right, if I was graphing this, I would only get about 5 out of 10 right now. I need probably 3 more things. 3 more things. A line connecting would be good, okay? So I'm connecting with a line. Okay, I need 3 more things, 2 or 3 more things still. Thank you. Did everyone hear that? You still have to go to 0 on the left. The domain says graph from 0 to 2 pi. The domain says the graph from 0 to 2 pi. So please make sure your graph goes down there. Okay. And probably a title might be good too. Okay, that's sort of coming back for some people, these graphs. Okay. Because you'll need that, and you'll also need the basic idea of sine and cos and transformations of that as an in-between step. We'll be graphing like monstrous things in this unit. In a good way. All right, I'm going to hit pause on the video. You guys take a second to catch your breath. Once your breath is caught, we'll move on to derivatives of sine and cos.